Hi everyone. I'm really glad I can kick off this meetup with a talk about the zero trust architecture, which is especially important in the context of the cloud systems that have gotten more popular over the time. Sorry for the technical difficulties. It was indeed a zero trust issue. So yeah, let's start talk about the zero trust. A few words about me. As Rafał said, I'm Piotr, but you can call me Peter as well, and I'm a principal software engineer here at JLabs, working with them for almost 3 years now. I'm a certified architect of cloud-based solutions and a cybersecurity enthusiast who's promoting secure by design approach, which is basically all about making the security a first-class citizen whenever you are designing new services. But before we start talking about the zero trust, let's go back in time a bit to medieval times, and let's have a look at this castle. So basically, castles were something that was considered extremely secure, at least in the medieval times, because, well, they had those tall walls, the towers, often surrounded by a moat with crocodiles and, armed guards in front of the gate. So basically, whenever you thought about something secure, you immediately thought about castles. But the castles had very weird security model. Basically, once you made past the guards, once you were inside the castle, you were considered a trusted person. So you could use different facilities inside that castle. And this obviously led to situations where inside the castle, the guards sometimes could let in a spy or an enemy. But, this was a long time ago. These were medieval times, so it was fine because those people weren't that advanced as we are now. However, the issue is that IT infrastructures have been operating in a similar way for a very long time, and they are operating in that way even nowadays. So the castle and moat model is sometimes referred to as perimeter-based security. And basically, it means that there is some perimeter inside which we consider every entity trusted, and everything outside this perimeter is not trusted. In IT infrastructures, this is very often some internal private network that you have in your company. And basically, within this network, you're running some services, some databases. You're letting your employees in, whether they are coming from the office or whether they are connecting remotely. Basically, once they are inside, they are considered trusted. And they have access to all those facilities like databases or applications that are hosted internally. And this is obviously a big security risk, right? Because you can't be really sure who's actually using, for instance, the VPN that you just provided. Just because somebody has a certificate and can connect to the VPN instance doesn't mean that it's actually them, because the certificate could be stolen. So it's very ineffective against insider threats, because once somebody is in, there is no way of verifying who that person is. And it's got really ineffective with the rise of popularity in cloud and hybrid environments. Because cloud environments, well, they won't be running in your network, right? So this security model doesn't really apply to those. The obvious downside of the perimeter-based security is the flat network structure. So it means that whoever got into the network, most often they can move in a lateral way, which means that they can access all the resources that are placed inside the network. Such network is obviously a single point of failure, and because very often there is a very high emphasis on securing the network itself by setting some firewalls and basically by making it difficult to let in, it often leads to ignoring data and application level security, because you think you're safe because your network is tough to breach. It has high walls and towers and guards, but it's very difficult. It's very easy to miss the other layers of security, for instance, data and application level. And before I will start talking about zero trust is, let me tell you first what zero trust isn't. So zero trust is not a new concept. So it's not like I'm trying to sell you some new fancy framework or anything. It was first, the zero trust term was first presented in 2010 in a paper for Forrester Group by one of the researchers. Over the time, it was getting more and more popular. It was also getting more standardized until 2020, which was a breaking point because NIST released a special publication which was basically a comprehensive set of guidelines and best practices for zero trust. And just 2 years later, in 2022, the US government mandated the adoption of zero trust principles in all federal agencies by 2024. So as you can see, this is something that was actually proven to be working to the point that, well, the US government actually forced all the agencies to adopt zero trust. And I especially recommend the NIST special publication. It's really a great lecture. It dives deeply into the core essence of the zero trust. So yeah, it's available on the website. Really, please visit it. And zero trust is also not a product. So whenever you type zero trust in Google, you may see different websites kind of trying to sell you zero trust as it's something that can be purchased. But it's not like that. It's not like you can buy zero trust and have it like 2 days later in your company implemented. Those companies are selling implementation parts that will help you achieving the zero trust. But overall, it's not something that can be simply bought or like really used just as software as a service, for instance. And that's because zero trust is actually a set of principles, and there are 3 main principles. It's never trust, always verify, least privilege access, and assume breach. And we will talk about every single one of them in details. So the first one, never trust, always verify, it's basically forcing you to get rid of this implicit trust and verify every user device and connection attempt before granting an actual access. And to grant this access, you should use contextual factors, such as time, location, device posture, to make this access decision. So it's not like with VPN, you're connecting once and you have the access. Here, with this principle, basically each request to a resource that is managed by your company needs to be evaluated. And obviously, for this sort of evaluation, multi-factor authentication is simply a must. And we are not only talking here about one-time passwords from your mobile phones, because it could be also biometrics, it could be also physical keys, but multi-factor authentication is a must-have layer when it comes to this principle. And here is a good example of how this principle works in practice. So we see that the same employee is trying to make the request to 2 different applications. And starting from the bottom, we can see what steps are taken in order to make the final decision about the access. So first, we always need to verify the identity of the user. So we are checking the credentials, we are checking the MFA, maybe some status, internal status of the user. And then we are verifying the access conditions. So we are checking the user profile in the context. So basically we are checking what is their location, whether it's known to us or whether it's a new one. Are they using a personal device, or maybe they are connecting from their own company device? And there could be like different set of contextual factors which you could use to basically make the decision. And the last point, the last set of data is verifying where the access is going. So basically you need to know whether the employee is trying to get the access to your production database, or maybe he's just trying to access some non-important service that is hosted only in your dev environment. Then all those conditions can be basically used to calculate a dynamic risk score. So here is the thing. The trust is very rarely a binary value. So it's not like you can either trust or not trust. Trust is more of a scale, and the result of that scale is indeed binary, because you can either grant the access or block the access. It's not like you can just give the access a bit. So you're based on those data that you have gathered, like the identity, access conditions, and where the request is going, you can compute the trust score. And then different resources can require a different trust score in order to be able to access them. So you can imagine that production database may require a very high trust score, maybe even a 1, but some small non-important dev application could be only requiring like 0.4. So it's very important to always evaluate the user posture, the requester posture, and based on all the conditions that you get, make the final decision about granting or blocking the access. And it does not apply only to users, because it also applies to your applications as well. If you have server-to-server communication, in this example it's client-to-server, but it could be server-to-server, you could use a mutual authentication, such as MTLS, in order to be sure that these applications are in fact them. Because without that, you can't really be sure if the application wasn't just impersonated by an insider threat. So mutual authentication really helps with that as well for application-to-application communication. The second principle is the least privilege access. It's about defining the access rights based on job functions and responsibilities, and doing that in a way that you grant those privileges only when they are needed and for limited duration. So basically, you can imagine that John, who's working in the accounting department, doesn't really need an access to production database, right? So basically, you define a set of privileges that are specific for a given role in your organization. And then instead of giving those permissions like permanently, you should rather define those permissions as roles that can be assumed for a limited time. And this way, you basically avoid granting anyone broad administrative rights that could be used if the account was taken over, for instance. Here is the example of such security policy. This one is coming from AWS. In this particular example, we are restricting the access to one certain table, but not only to the table, we are also restricting access to specific columns in that table. So as you can see, those solutions can allow you to specify really granular level of permissions, because it's not only table, it's also what columns can the role holder access. So it's really important to make use of those capabilities. And when it comes to those roles I've been talking about, basically, you should never give the role permanently to anyone. It should rather work in a way that the employee or even an application assumes the role for a limited time. For instance, in AWS, this is done by the STS. And in return, you're getting temporary security credentials, which can be used to perform operations, but only on the resources that have been specified in the role. So even if those credentials are going to be stolen, they cannot really be used for much more things. They have like a very, very specific use case. And also they are temporary, so they will expire. And also probably you should have some access to revoke those permissions anyway if they are stolen. So this is also something that should be incorporated to fulfill this principle. And the third principle is very interesting because assume breach. It says that you should always assume that your network is compromised. It's not only network, it could be basically your organization. So at any point in time, you need to assume that there is a malicious actor inside your organization who's trying to do some harm. This enforces you to think in a bit different way whenever you are designing some architectures or thinking about the data or data flows. Because obviously, if there is someone who's trying to get your data and steal your information, you need to implement data protection measures. So both you need to have the encryption at rest, in transit, and also possibly between applications, so there could be no man-in-the-middle attacks. And it's also very important to segment the network in a much smaller regions. So instead of having like a one big network, because well, even in cloud, there are networks inside, internal networks, you should rather create smaller network units that can communicate between each other, but avoid having this one big network in which basically the attacker could also move laterally. And assuming that there is someone who doesn't have good intentions, then continuous monitoring and analytics is also something that you simply need to incorporate, because you need to be aware of anything that is happening inside your infrastructure. So any audit logs, any behavioral analysis, this is something that you should have in your system, because this gives you big visibility and it allows you to detect the threats very early. Here is the example of how the micro-segmented network look like. So basically we have 3 departments here, finance, sales, and infra, and each of them has their own networks, and those networks can communicate with each other, obviously, because sometimes they need to. However, the thing here is that in the flat network structure, if you have, well, malicious actor inside your network, they can basically access anything. With the network that is segmented, this access is much more difficult, because even if they get into one micro-segmented network, in order to be able to move to their target network, they need to make some hops. They need to know the flow. They need to investigate how those networks are connected between each other. This usually requires more time and also more skills from the attacker. So when you have a proper threat detection, then the segmented network grants you basically more time in order to detect that somebody tries to access your network in unwanted way. When it comes to the benefits of introducing zero trust, well, there are many of them. Like enhanced security is out of the box, right? For me, what is often missed is the scalability, because once you define all those policies, once you have the trust algorithm in place, this is something that scales extremely well with the amount of employees your organization have, or with the amount of resources that you are using, because you already have those policies defined and aligned. So rolling it out to more people or more resources is really easy. And the second thing that is sometimes overlooked are the cost savings. So this is interesting because, well, to implement the zero trust, obviously you will have to spend the money, because those implementation pieces, well, they cost money. But in the longer run, the zero trust can also save you money, because you can imagine that if you have a data breach, if your data is stolen, then especially in EU with the GDPR regulations, you would be fined. And those fines are sometimes very severe. You could also be sued, obviously. Not speaking about reputational damage, obviously. But if you implement those principles in your systems, then basically any data breach is limited to the least possible extent, because the data is protected. The attacker can only access certain network, and the possibility of breaching the trust algorithm is much lower. So in the longer run, this also gives you some cost savings. As for the adoption, so I would say there are 6 steps that need to be taken in order to introduce the zero trust in your organization. From all those 6 points, I would say the most important one is the second one. So conducting a comprehensive assessment. Why? Well, because basically it defines really all the further steps, and it's inherently important to be able to assess what resources are most critical in your company. Like, what is the actual core business, core domain that is, for instance, making most of the money? Where do you hold most sensible data? So this is very important because based on this assessment, you are building the trust algorithm. You're building the further adoption plan because, well, after implementing zero trust for some not that important part of the system, you would most likely want to roll it out to the most crucial pieces of your company, because by that you get the most benefit out of it. And yeah, it's just very important to do this assessment right, because if the assessment will be wrong, then the whole implementation of the zero trust won't get you the effects that you would get if you would get all those pieces right. What is great about the public clouds is that, well, whenever you're using any big cloud provider, no matter whether it's AWS, GCP, or Azure, all those big providers are coming with certain components that can help you implementing zero trust. It's especially easy if you're relying on a single cloud provider. But yeah, basically, any of them, they have all the pieces needed for identity and access management, MFA, network security, data protection, monitoring. It's all there, and you can use it, and you should use it, because yeah, those native cloud capabilities, they really integrate well with all the other solutions. This gets a bit more complex if you're using a multi-cloud setup. So for instance, some of your resources are placed in Azure, some other resources are using AWS. So this is difficult because obviously you should still facilitate those native cloud capabilities, but it's difficult in managing them in the longer run, especially with big systems, because doing this manually is really cumbersome. So what I've seen in some companies is that they are, whenever they are working with a multi-cloud setup, there is high chance that they are already using some infrastructure as a code tooling, such as Terraform. And those companies were trying to create their own custom cloud agnostic modules that would basically encapsulate all the resources related to the zero trust, such as network security or identity and access management. And then they are providing a translation layer. So basically, those resources that then need to be created either on GCP or Azure. So once you have this translation layer in place, then basically it brings you this big benefit that you can think about the security on your own rules, because you don't need to think about it in the context of Azure or AWS. You can always think about the zero trust and its components in your own context that you have created within this module. This obviously looks nice and easy, but each cloud provider usually comes with some nuances that are specific to their offering. So it's not as easy as it seems, but it's possible. I've seen it myself. It's possible to create such custom module to some extent. And the whole setup gets inherently difficult when you're using a hybrid cloud setup. So basically, whenever you're not only using multi-cloud providers, but maybe some of your applications you have hosting yourself in your own data centers on premises, or maybe you could be also using some external software as a service applications. So then obviously it's very difficult to manage the zero trust by some Terraform or even manually. It's virtually impossible. So what you most likely need is a thing called zero trust network access. And it's basically a separate component, sort of a middleware between your users and resources that encapsulates all these principles and all these steps that have been happening in a single place. So basically, if the user makes a request, for instance, to reach some application, this request first goes through the zero trust network gateway. And in this gateway, we have multiple identity providers. we are checking the device security posture, we are checking the contextual factors, and if the trust algorithm is saying that yes, this request is permitted, then the zero trust network establishes the connection between the user and the resource on the other end. So basically, because you have so many applications, cloud systems, on-premises services, you need to have one centralized place that could help you managing all of these policies, and that's why the zero trust network access is mostly needed. You could build your own ZTNA, but most often companies are using external providers such as Zscaler or Cloudflare. And just as a summary, you need to remember that zero trust is a journey. So it's not like it could be achieved overnight. It's a process. It's a final destination that you should strive for and push for, but it's a journey. And obviously, there will be some learnings. There will be some mistakes. But the journey itself, it's definitely worth it, because at the end, well, you are more secure. And in today's world, with evolving cyber threats, I think it's especially important. Thank you very much. And yeah, I'd be happy to answer any of your questions. Thank you.